Learning Target 14 says I can apply summation identities to evaluate sums given in sigma notation. So in these problems, you're going to be given a sum written in sigma notation, like this, for example, and you're going to be trying to evaluate the sum. And evaluate means to find the value of the sum. Now, for Learning Target 14, it's about applying summation identities. So in order to get credit on Learning Target 14, you need to actually be finding the value of the sum using summation identities. If you don't use summation identities, you won't get credit for completing that problem. And summation identities are that list of formulas and properties about sums written in sigma notation. I wasn't able to fit the list of all of them on these slides, so I'll be sort of just telling you what they are as we go along, but it would probably be a good idea for you to have that list of summation identities in front of you. It's in your notes, it's in any practice quiz or quiz that I've ever given you on Learning Target 14. It's a list of 5 different properties or formulas involving sums. So it would be a good idea for you to have that out in front of you as we're working through these. So the summation identities I'm talking about are, there's one that says that if you have a sum inside of a sigma, you can rewrite it as the sum of 2 separate sigmas. One says that if you have a constant multiplied inside the sigma, you can multiply the constant outside instead. One of them is a formula for if you have just 1 on the inside of a sigma. One of them is a formula for if you have just k inside of a sigma, and one of them is a formula for if you have something of the form r to the k inside the sigma. And so our goal is to sort of break it down to the point where we can use those formulas that I just mentioned to actually find the value of the sum. So whenever I have a problem like this, I first look for inside the sum, is it just a sum of 2 separate things? Is the formula on the inside just a sum of 2 separate things? Is it just the product of a number and a variable? Like, what's going on the inside? If you ever have a sum on the inside of a sigma, you can always break it up into the sum of 2 separate little sigmas. So what I mean by that is that I can instead write this as the sum of negative 2k plus the sum of 4. So whenever you have a sum on the inside of a sigma, you can break it up into 2 separate sums. And that might be useful because it might get it to the point where we can use those formulas that I mentioned on your sum identity sheet. So the next thing I look for is, in each of these cases, is there a number just multiplied on the inside that we can pull out in front of the sigma? So in this case here, we have negative 2 times k on the inside of our sigma. What we can do is we can pull the negative 2 out in front of the sigma so that we're just left with k on the inside. Now, a really common mistake is that people want to write this, don't write this down, people want to write this instead as like the sum of 2 times the sum of k. That's not what the sum identity is saying. It's saying that if you have a constant on the inside of your sigma, you can just pull it out in front and multiply it on the outside rather than on the inside. So when you have something that looks like this, you can pull that negative 2 that's multiplied inside, you can multiply it on the outside instead. Now, on this one, it doesn't really look like you have a product on the inside. But what I'm going to do is I'm going to think about this 4 as being 4 times 1 and bring the 4 to the outside the same way that we just did, and we'll see why in just a minute. So in the same way that I looked at this as being negative 2 times k, and I pulled my negative 2 out in front of the sigma, here I'm going to think about 4 as being 4 times 1, and I'm going to pull my 4 out in front of the sigma. And I'm just multiplying these in front of the sigma. It's not like the sum of negative 2, it's just negative 2 on the outside here. Now, the reason why I did this was because now we see that we have little parts that we actually have formulas for on our sum identities sheet. So on our sum identities sheet, there is one sum that says the sum of k from k equals 0 to n is equal to n times n plus 1 over 2. We also have an identity that says that the sum of 1 from k equals 0 up to n is equal to n plus 1. So the idea is that if we can ever have something that looks like this, we can just replace it with this formula here. If we ever get to the point where we have something that looks like this, we can replace it with this formula here. So that's my goal, is to sort of get it down to these simpler looking sums that we actually have formulas for. Then we can just plug into the formulas and evaluate. So in this case, I was trying to get it down to the point where I had just the sum of k instead of having a negative 2 still inside there. Because if I can get it to just have a k on the inside, I can use this formula. Similarly here, I knew that I had a nice formula for the sum of 1, so I was trying to get it to the point where I just had something that looked like the sum of 1, and then I'm going to be able to just use this formula. So let's take this piece by piece. Let's first look at the negative 2 times the sum of k part. So my negative 2 is going to stay on the outside. On the inside, I'm going to use this formula here to rewrite this part. So notice how this looks exactly like this, except this has an n on the top and this has a 5 on the top. So what that means is that our n value in this case is just 5, and I'm going to plug that in everywhere I have an n in my formula. So I'm going to get 5 times 5 plus 1 all over 2. So all I did here was I recognized that I had the sum of k. I have a formula for the sum of k. What's different is that this actually has an n value, so I knew my value for n that I could then plug into my formula. So I'm just rewriting this using my formula. The next thing that I need to do is work on this piece over here. So once again, I'm going to leave the plus 4 alone for now, and I'm just going to focus on this piece here. So I know that I have this formula for the sum of 1. If you notice, the thing that's different about this sum and this sum is that the number on top is a 5, not an n anymore. So I know that my n value is 5, so I can plug that 5 into my formula, and I end up getting 5 plus 1. So now at this step, all that I have to do is simplify down. So let's work inside the parentheses first. Okay, so here I still have negative 2 on the outside. On the inside, I get 5 times 6 over 2. Inside these parentheses over here, I get 6. I can keep simplifying inside these parentheses. 5 times 6 is 30, divided by 2 is 15. So I get negative 2 times 15 plus 4 times 6. So now here we have some multiplication and some addition. Following order of operations, multiplication happens first. Negative 2 times 15 is negative 30. Positive 4 times 6 is positive 24. And then I can just add to get my final answer, and I get a negative 6. So let's move on to another example. So in this example, we have something a little bit different. We're going to have to use slightly different sum identities, but our goal is still going to be the same. Looking at our sum identity sheet, we have a few nice simpler sort of looking sums where we have a nice formula for them. So what we're going to try to do is we're going to try to get our sum to look like those simpler sums that we just have a formula for. Okay, so on the inside of this sum, I always like to check, is it just like something plus something else? Is it just a sum on the inside? In this case, it's not, so we can't break it up as the sum of two separate sigmas. However, if you notice, we have this 3 to the k piece, over here, and that's all being multiplied by this constant 2. So the second sum identity on your sheet says that if you have a constant multiplied inside the sigma, you can multiply that constant outside instead. So what we can do is we can write this as 2 times the sum of 3 to the k from k equals 0 up to 4. So instead of multiplying by 2 on the inside, I can multiply by 2 on the outside instead. Now, if we look at our sum identity sheet, if you look at the very last one says that if you have the sum of r to the k from k equals 0 up to n, that is equal to, sorry, I'm running out of room a little bit. That is equal to 1 minus r to the n plus 1 all over 1 minus r. So that looks pretty complicated. But what I want you to do is just sort of look at this piece here, this sum, and look at this piece here, this sum, and if you notice they look pretty similar, except this one has numbers in some places where this one has letters, right? So they both have the sum, they both have k equals 0 at the bottom. On the inside they have something raised to the exponent of k, and then on the top of the sum they have something else. So this is really something in this format, just with certain numbers plugged in for r and n. So in particular, we can see that our n value is 4, and we can see that our r value is 3. So what we're going to do is we're going to plug in 4 for our n value, and we're going to plug in 3 for our r value, and simplify down. So over here on our sum, we're going to leave the 2 on the outside, and on the inside, we're going to rewrite this sum using this formula here. Now, we just figured out what our r and n were, so we want to plug those values into our formula. So we have 1 minus 3 raised to the 4 plus 1 power over 1 minus 3. Now, we just need to simplify this. Now, you sort of have to be careful because there's, lots of little pieces here and it's easy to go in the wrong order. We do need to make sure we follow order of operations. So we're first going to work inside the parentheses, and then within the parentheses, the next thing that comes is exponents. So if you notice there's an exponent here. So on the inside of this exponent, that's going to be 4 plus 1. So what we really have here is we have 2 times 1 minus 3 to the 5th over 1 minus 3. Now that we have this exponent written just as a number, we can simplify a little bit. 3 to the 5th is 32. So we have 2 times 1 minus 32 all over 1 minus 3. Now we want to be able to do this division, but let's first try to simplify on the top and on the bottom separately, and then we can do the division. So we still have 2 on the outside. On the inside, on the top, we have 1 minus 32, which is negative 31. On the bottom, we have 1 minus 3, which is negative 2. Now we can keep simplifying a bit. We can do negative 31 divided by negative 2. If we actually did that out, we would get 15.5, or 15 and a half, however you want to write it. And then we can multiply by our 2, and we end up getting a final answer of 31. So let's just quickly review the steps in these problems. So the first thing that we're going to do is we're going to look at our particular sum, and we're going to try to manipulate it using our sum identities to get it to the point where we're able to use these sum identity formulas that we have on our sheets. So if like there's a sum on the inside, you can break it up into the sum of two separate sums. If there's a constant multiplied across the entire inside, that constant can be multiplied out in front instead of on the inside. So once we get it down to the point where our original complicated looking sum has a bunch of parts that are a little bit simpler, then we can just go to our sum identities and use our formulas and just plug into those formulas to find the values of the sums. And then it's just sort of a matter of simplifying down until we get our final answer. So with these problems, we should always end up with an actual final answer, like a final numerical answer for our sum. Now I would encourage you to make sure that as you're doing these practice problems that you have the sum identities sheet in front of you. I'm guessing that you probably don't have all these formulas memorized, so make sure that you have a sum identities list in front of you as you're doing practice problems on this learning target.